Welcome to ArmanisMath. This is lecture number 12. We are going to be solving trig equations. First thing is going to be our warm-up, and I'm going to give you about a couple minutes for this warm-up. I'm going to put the timer here. Since we're recording, most likely I'm going to pause it prior to that. 2 minutes, but we're just going to give ourselves 2 minutes here. Okay. All right. Number 1 and 2 are obviously straightforward algebraic first degree equations. So just do some manipulations for that. And number 3 and 4, I would highly recommend that you choose the unit circle. If you are watching this video after this lecture is being live recorded, so I'll probably pause here and give yourself about a couple minutes, or I'd probably say a couple minutes should be fine. But I'm gonna pause in a few seconds, okay? Okay, so I'll stop here and then we are just going to start the journey, okay? So now, first question is this. I need to solve the first equation. So I'm going to go up here. And help me in the chat, by the way. If you got some answers, I'd really love to read your chat, because I have a couple screens here, so I'm going to follow along, see what you guys have. If you have any answer for number 1, go ahead and chime in the chat. Okay, that's good. So I basically have to subtract 2. And that is going to give me x equals 3. And that's the answer for the first one. Okay. Second one, I'm going to do a similar approach. Plus 3. Plus 3. That's going to give me, I'm going to give myself more room here, okay? So that's going to give you 3x equals, I've got the 12. And if I divide this by 3, x will be equal to 4. Okay. And this next one is going to be, I see that in the chat. Awesome job. The next one is going to be the trig function. So I'm probably going to use my tool here to draw myself a circle. Okay, so this little tiny circle like this. And I'm just going to do like that. And like this. And start to think. So sine 30, what angle has sine 30? Apparently I'm here with sine 30, and I am probably somewhere, maybe there's a different color for that guy. So I'm here, and sine 30. So I know that this guy has square 3 over 2. Comma 1/2, and we said every cosine is the x. So this is cosine, and this is sine. So this is the y, this is the x, and if they wanted the sine, that means they wanted the y side of the x. So y equals 1/2, or the sine is equal to 1/2. Okay, so the answer for this guy is 1/2. Okay. Excuse me. The fourth one is equally amusing. We are going to use we're going to use the same concept of the unit circle, since we worked so hard in the last lectures to learn that. So here's my unit circle, a little bit tiny here. Let's see. Let me rephrase that. Let me actually. Let me undo that and just give myself a little bit more room. Okay, here we go. So I'm gonna go here and I'll probably start from here and down here, and I'll probably start like this, as close as possible. Okay. Here we go. And then 3 pi over 2. Well, this is 3 times the pi over 2. The pi over 2 in my mathematical brain, this guy here is 90. So you're saying 3 times 90, which is 270. So I am down here basically at 270. What are they asking here? What's the point actually here? What's the Cartesian coordinate points? What's the order pair? Well, it's 0, -1. Okay, 0, -1. Feel free, by the way, to chime in the chat. You guys are doing an awesome job. I see a lot of you are putting some answers. So I am going to look at the point here. I'm going to decide how do I get the tangent. Tangent, if you remember from last time, tangent is y over x. And in this case, it's going to be -1 over 0. I'm pretty sad. That's not right. Yeah, that's not true. I should say this is not desirable, but that's what we've got. It's undefined or does not exist. However you want to slice it, you're going to get a frown face for that thing. All right? So that's what we do for the warm-up. Undefined. And here we go. What we're going to do today is use algebraic techniques, just like in the warm-up, to help us solve trig functions, along with obviously the inverse trig functions. First thing first, it says find all solutions to the equations in the interval 0, pi. A quick just preview on the 0, pi interval. According to the interval notation, if you have a if you have an interval that looks like this, the one that you like this here, like the bracket 0, bracket 0, pi, and then parentheses. I'm just reviewing here. This bracket means it's included. Include this value. Okay, so this value is included. This value, however, if it's parentheses, you are not including that. Not. Parentheses are not. This parentheses here, not included. Included. Okay, so just keep that in mind. This is just a quick review for the parentheses and the bracket. Basically, what they're saying, you could look for angle as your solution. It should be an angle that is between 0, including 0, and all the way to pi. All the way to pi. Well, how much is pi? Does anybody remember how much is pi? How much is pi? Is it 360? Is it 90? How much is pi? So help me out in the chat. How much is pi? Come on. You know this by now. Help me out, please, in the chat. How much is pi? All right. So this pi is actually 180. You're saying that you are between 0, including 0, and all the way to 180, but not 180. Okay? Not 180. So let's take a look here. Cosine theta is 1/2. I have to think a little bit here. Cosine theta is 1/2. So what angle is this theta? What is this theta? What could this theta be? Theta equals what in this case? Well, if you looked at the unit circle once again, our friend the unit circle, we would come here and just graph ourselves this dude here. And with our mathematical ability, I'm gonna here, and we're saying two things here. Cosine of an angle that I'm looking for is 1/2. Remember, we are looking for the angle. I gave you the value, but I'm looking for the angle. So there's a couple ways to do it. Obviously, they have a solemn warning here: do not use calculator. It says here, without calculator. So that's why we depend on the unit circle for that. So cosine of the angle is 1/2. Now, could this be 60? Yeah, could be 60. I don't think. Why couldn't be? Could be 60. The reason is 60 has 1/2, comma, square root 3/2. So this is the cosine, this is sine. So it could be 60. Okay. By the way, 60 is pi over 3. Obviously, pi. So now let me think a little bit here. Could it be something else in this interval? Could it be something else in this interval? Well, it really depends on your knowledge of the unit circle. Recall what we said about all student take calculus, just this little mnemonic thing that we used to help us. Here's all student take calculus. So where is 60? Well, there's a 60 here. It's 60, right? And there's also another 60 here, but the 60 has to be positive. If you look closely, this is positive 1/2. So basically, you're looking for the quadrant that has a positive cosine. Positive who? Positive cosine. Okay? So first quadrant, obviously, all of them are positive. Second quadrant is negative for cosine. So I'm sorry, that's not going to work. It's tempting, but it's not going to work, because if you want to pick it here, if you want to pick something here, saying this is 120, for example, that is not going to work, because your cosine here is negative, and that's not what you want. According to what's given to you here, this says this is positive 1/2. So the only option here is actually just the 60. Now, what if we opened up this interval a little bit? For example, what if I said from 0 to 2 pi? Then you would probably think about, oh, okay, so I have another cosine possibility down here, which is using the same reference angle 60. So you go down here 60, and you're going to find yourself at 300 if the interval is open all the way from 0 to 2 pi. But it's not. I'm sorry, it's not. So right now, that's what we could deal with. Only the 60 is possible. Only the 60 is possible. And again, pi over 3 is another just another name for the 60. Okay, number 2. I like what I'm seeing in the chat. That's very nice. Yeah, okay. Let's stay focused here. Okay. Sine theta equals 1. Sine theta equals 1. I'm still in the same interval between 0 and pi, or 0 and 180. And I have to think a little bit. Sine equals, okay, so I'm going to depend on my unit circle. Why? Because it says do not use calculator. No calculator. Sure. I use my awesome ability in the unit circle. And this, okay, a little bit awkward, but that's okay. And I would come here and be consistent. So I'm going to use this color and this color. You like this color? You like green? Tell me in the chat what's your favorite color. In the chat, please. What's your favorite color? Come on. Come on. Come on now. Come on. Favorite color in the chat. All right. So I'm going to go here. And it says sine of the angle is equal to 1. Remember, I don't have the angle. I have the value for it. So for example, I gave you $20 and say I say, what can you buy for $20? Well, it could be a shoe, a shirt, or something. So I didn't say what is it that you're going to buy. I just gave you the money. I gave you the value. The same thing here. Sine of the angle, the value is 1. That's not the angle. That's the value of the angle. So how do you get the angle? Well, that's exactly what we're doing here. We're going to put that in the unit circle and see. Where is that sine equal to 1? Okay, so I'm probably going to think, is it going to be here? Well, this point here is 1, 0. So it's not sine. Is it going to be here? 0, 1. Oh my gosh. I think it's here. Because sine is the y. You're looking for the y. And the y of this angle here is 1. That's why your theta is 90 degrees. Or pi over 2. Okay? It's either this or that. This, it's the same thing. Just a different name. Just like kilometers and miles, Fahrenheit and Celsius. They're just the same thing. Okay, so it's either 90 or pi over 2. All right? Okay. Okay, in the chat, you guys, stay focused, okay? Tangent theta is 0. Now, that's a tough one. Tangent theta is 0. Tangent theta is 0. Tangent theta is 0. Okay, back to my, because I'm not allowed to use a, okay, use a calculator here. Okay, no problem. You still survive. You still survive. Yeah, you would. And then let me, again, come here, and start from center, go up, from the center, go down, and then sideways. And let's go back to this dude here. So tangent is 0. Now I have to think again, could it be here? What's the point here? Well, this point is 1, 0. And this point is 0, 1. Okay, so I'm gonna just think a little bit, and this is, by the way, this is 0, -1, and this one is -1, 0. So now I have a question. Tangent theta equals 0. What is the angle that you're looking for? Tangent theta equals 0. Okay, so it has to be 0 at the top. 0 is the y. I'm dividing that by the x because I want to end up with 0. Remember, if you want to end up with 0, it has to be at the top, not the bottom. If you put the 0 at the bottom will give you an undefined, sad-looking face. So that's why you need the 0 at the top. There's nothing wrong with the 0 at the top. Anyways, so which one would have the y of 0? I'm looking at two possibilities here. It's either this dude, this guy here, or this gal here. Either this guy or this gal. I'm not sure. Or this guy and this guy. Well, am I restricted? Well, look, see here. Look at this here. Are you restricted? So I could use both of them, which is true, but am I distracted? Well, I'm sorry, you are restricted. This here says you are 180 exactly, and that's not what you could have. So that's why you should reject this possibility. The only thing that you have here is tangent of 0 degrees. So theta equals 0 degrees. Let me spell it out for you down here. Tangent is tangent y over x. Let me give myself more room here, which means for 0 degrees, this one here is going to be 0 over 1. And you know what? This is actually going to be a big happy 0. There's nothing wrong with this guy. Yep. That would work. That should work. Okay. So the angle is 0. Okay, here's another one. Come on, get ready for the fun. Let the fun begin. I have to speed up a little bit, okay? It says here use or find all the solution to the equation in the interval 0 and 2 pi. Oh my goodness. So now we're getting wider. We have more selections, more options. You got from 0 all the way to 2 pi, like from 0 to 360, okay? Now, without a calculator again. So they're asking you not to use calculator again. Oh my gosh. No calculator. Okay, no problem. No calculator, no problem. So let me go back here. And I'm going to... I can't use the inner circle yet because I have to think. I've got this. I have to modify things, I guess. So first thing first, I have to divide this by 2. That's going to give me sine x, sine theta, or sine x equals negative 1 over 2. I'm going to choose a different color for this negative because that's important. Now I have to think. Which angle has a sine of negative 1/2? Okay, back to my unit circle. Which angle is sine of negative 1/2? Okay. Which one do you think? Which one do you think? I think you know. The sine of 1/2 is actually a 30. So I'm going to go back here and put 30. Perhaps that's okay. 30. Because the value for the cosine is of this dude is square of 3 over 2 comma 1/2. Okay, now I have to think, is this actually a positive or is it negative? Well, this is positive, but knowing what I know about the unit circle, all student take calculus, I'm just able to reflect this. I'm able to reflect it to see wherever the sign is negative. Well, the sign is negative, believe it or not, if you extend this line here, and remember this is your 30 reference angle, which will give you an angle of, you got basically 180 plus 30, that's 210. That's a possibility. And also, where is sine negative? Well, it also happens here, if you remember. Happens here. So I also have a 30 down here, a 30 down here. Why is it acting up like that? A 30 down here. This is 30, and this also happens to be a negative. So this guy would be at 330. And this would have a negative value for the cosine. So let me make this just a little bit. So the cosine here is going to be negative 1/2 comma square 3 over. I'm sorry. Am I doing the sine? Cosine is what I'm talking about. Square 3 over 2 negative and comma negative 1 over 2. That's one of them. Also, this guy here has square 3 over 2. Comma negative 1/2. So there's two possibilities here for me. Either this here or that one here. So two possibilities that I could pick for this, and that's what my theta is going to be, either the 210, or my theta also could be or theta could equal to 330. What's 210 in pi radians? Well, remember in pi radians, if you could go back to lecture number 5 and lecture number 6, or 4 and 6, you would find out that we're splitting this pi here by sixes. So 1/6 is 30, 1/6 of the pi, 6 sixes is, and then 7 sixes. So this guy shows 7 sixes of the pi, 7 pi over 6. Okay, that's 7 pi over 6. 7 pi over 6. Let me just give myself more room here. 7 pi over 6. And the other one is, I'm going to keep adding sixes. Apparently, if I land on 11 pi over 6, that's 11 sixes of the pi. 11 sixes of the pi will give you exactly what you need, which is 330. Okay, so that's because my range was really increasing here. That gives me broader choices, more choices. Okay, here's another one. And this one is it says now you are kind of limitless. You are limitless, meaning you could go from negative infinity all the way to infinity and beyond, Buzz Lightyear. Okay, well, find all the solution to the equation in the interval, and then from negative infinity to infinity, obviously not including them because you can't really hug infinity. It's too big. And without a calculator, again, yes, don't worry. We're going to use calculator today. Do not worry, okay? Those of you who are calculators freak. I know some of you. I could name names, but I'm not going to do it. Anyways, so it says use without calculator, and then I would definitely use the unit circle. So let's just clean things up a little bit here before we get started. I've seen 1 minus 2 cosine theta. I can't do anything about this yet before I get rid of that 1. So I'm going to subtract 1 from both sides in this case. Subtract 1, which will give me a line like this, and I will end with a negative 2 cosine theta equals negative 1. Okay, not bad. And now I could divide by negative 2. Negative 2 cosine theta equals 1/2. Interesting. Cosine theta is 1/2. Oh my gosh. Oh my gosh. Cosine theta is 1/2. Let me go back to my unit circle because that's really becoming exciting now. Cosine theta is 1/2. Come on. I know that. I know that. I know how to get that. Here we go. Cosine is 1/2. Okay. Cosine theta is 1/2. And I believe cosine, could you chime in the chat? Well, cosine, what angle gives you 1/2? I know there's a delay obviously here, but in the chat, but in the live stream. What do you think is cosine 1/2? What angle gives you cosine of 1/2? Interesting. Before you think about that, I'm going to put all students take calculus just to remind me about my positives and negatives. So I'm looking for a positive, obviously a positive half. That's a positive. Different color for this guy. Positive half. So cosine is positive here. I could land here, or I could land here. Okay, is that true? That is true. Yeah, because all of them are positive here. Sine, cosine, sine, and tangent. And here also. Cosine, sine, and tangent. Oh, I'm looking at a beautiful bird right now on the tree. That's interesting. Very lovely bird. Wow. Okay, anyways, let's focus here. These two quadrants, quadrant number 1, quadrant number 4, these two would have a cosine that is a negative. The negative cosine, I should say, yeah, positive cosine is what I meant. These two quadrants would have a positive cosine. According to what I need here, I need a positive cosine. Okay, so let's think a little bit here. What is the angle that gives me a cosine of 1/2 in the first quadrant? What's the angle that has a cosine of 1/2? And my brain is going, oh my goodness, I know this, Armani. Just a second, Armani. I know this. What is it? What is it? In the chat, what is it? What is it? What could that be? What could that be? Okay. Oops, I'm sorry for this there. Trying here. Anyways. Oh, Lord. What could that be? Yes, thank you. I waited a little bit, so this is actually 60. 60 has a cosine of which is 1/2 common square of 3/2. 60 is. Now 60 is correct, and I love it. And if you guys remember what we've done with the unit circle, the beautiful. There's 2 names for that thing, by the way: the beautiful and the attractive unit circle. Lecture number 6 and 7. Check that if you're not sure. So I just reflected here. I just reflect. I know that I have a 60 as a reference angle down here as well. So that's going to give me a 300. So both 60 and 300 are good options for me. 60 and 300. So theta, I'm going to put it here. Theta could have two options, either 60 degrees or 300 degrees. Now, what is 60 in terms of pi radians? Well, we know that if you slice the pi, if you take the pi, slice that into 3 pieces, that's 1/3 of the pi. 1/3 is 60. Okay, so 1/3 of the pi, which is, so this is pi over 3. And this is how many 60s do you have? How many thirds of the pi do you have? Well, you keep counting. Here's 1/3, 2/3, 3/3, and then obviously we keep going down here. 4/3, 5/3. 5/3 would land you here. So this is 5 pi over 3. Okay, we are so good if and only if the interval was from 0 to 2 pi, meaning the limit you from 0 to 360. But is this the case here? No, it's not the case here. Here they're saying sky's the limit. It's limitless. You could keep rotating. You could keep spinning until you get dizzy. So how do you count that? How do you say that in math? Spinning until you get dizzy. Well, you have the ability to say that in math. You just have to add, I'm going to change the color. Change the color. You just have to add the following. You just have to say this is plus 2 pi, like a whole rotation, n times. Like 5 times, 6 times, 7 times, n times. This is n, this is not h. This is n times. Also here, how many from that angle do you want to rotate? Well, I could spin. Sure. 2 pi n times. 5 times you want to? Sure. 6 times? Okay, what if I want to spin backwards? Yeah, you could spin backwards. Just like the microwave sometimes. You put it and then it just revolves in the other direction. Counterclockwise, clockwise. You guys remember that? Counterclockwise, clockwise. So this n actually could be positive or negative. That's positive, a number like positive 2, for example. Or it could be a negative number. This n could be positive or negative. You just pick a direction that you want to be dizzy at. And yes, I like positive. Sure. I like counterclockwise to get me dizzy. Sure. I like clockwise. I like to be dizzy clockwise. I like to be dizzy clockwise. I like that. Okay. Yep, you could choose that. You could choose to be dizzy clockwise. All right. So that's what you get from this one. Are we ever going to use calculator for this one? Yes. Yes. There will be calculator examples coming up soon. Get ready. Okay. Here we go. Oh. I just could remember. Oh my goodness. I remember those of you who are really calculator freaks. Well, here's your chance. Here's your chance. With a calculator. Woohoo! I don't actually like calculators, but just for those who like calculators. Because you depend on them and they give you approximate answer. They never give you exact answer, by the way. They give you approximate answer. Anyways, so calculators. This says cosine of the angle is 1/6. Well, if you gave me 1/2, I could say something like 60. If you gave me 1, I could say it's 0 degrees. If you give me something on the unit circle, I would know on the 16-point unit circle. But beyond that, I actually don't. So that's why for this here, for cosine 1/6, I don't know this. I have to use a calculator for. So here's what you do. You actually say cosine inverse of this amount will give you, if you put cosine inverse of 1/6, that's going to give you your theta or your angle. So you basically have to go to your calculator and then punch that in. And I'm going to do that right now. You go the inverse. Most calculators would have shift and then the function itself, or second and then the function, depends on your calculator. Mine here has a second and then the function. So second cosine, I'm going to plug in second cosine, and then I'm going to put 1 over x, 1 divided by x, by 6 I should say, 1 divided by 6. And I land on I land on theta equals 80.405 dot. Okay, I'm gonna approximate that, and that's why we don't really use calculators unless we have to. About 80 now, because you're approximating things. About 80 degrees. Okay, that's the calculator answer for this one. Why did I use a calculator? Well, because I don't have a value for 1/6. I don't have that. I don't have in my brain a capacity to remember stuff like that. 1/6, come on. You're talking about half maybe. 1, square root of 3/2, square root of 2/2 for 45, but 1/6, come on. Give me a break. Yes, you have a break. Use it. So now tangent is 2/3. Same thing. I'm going to go to my calculator. I'm going to put tangent, inverse or inverse tangent of the amount. Like, remember the example of the $20 and then you're going to buy a shoe or something. So now I'm going to tell you exactly what are you going to buy for $20. That's exactly what you're saying here. What are you going to buy for this amount? And then that theta is going to be the shoes or the shirt or whatever you're going to buy. So I'm going to go back to my calculator here, and I have mine here, second tan, and I'm going to put the value 2/3. And I'm going to land with, help me out by the way, in the chat, go ahead and do the problems, don't wait for me. You see them, do not wait for me. Theta equals, in this case, is I have 33.69. And maybe this is going to be 33.7. And that's why we're approximating here. I approximate by putting this squiggly line. So it's kind of a squiggly tilde and then a line under that. It's not equal. And I'm probably going to say 33. You're probably not going to like that, but maybe I'm going to put 34. Okay. It's not exactly that, but approximate. I'm approximating here. Okay, approximating. Okay, here we go. I'm gonna do that here. And the last one for this trio is sine theta is 7/8. Well, same deal. I don't have a capacity to do this. If you gave me sine theta is 1, I could help you. If you gave me sine theta is 0, I could help you from the unit circle. 7/8, what is that? Well, that's why you have to use a calculator for that one. Sine, inverse sine of this amount will give you your angle. Will equal to your angle. Hello? Equal to your angle. So your angle, you just have to punch that in. So I'm going to put second sine from my calculator. And that's going to give me about 61. 61.04. 61.04 ... Obviously, there's more numbers here. And I'm going to approximate this again. So this is approximately 61 degrees. Okay. And that's how I got the answer for this one. All right. Awesome job, you guys. I see the chat. Awesome. 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 Okay. Awesome. Here we go. Now, with the calculator again, but now they're giving you kind of some spices on top of this problem. Just a little bit spices, not too much spices. Yeah. I love spices. Love hot spices. Ooh, yeah. Okay, here we go. 5 sine theta minus 2 equals 0. 5 sine theta. Okay, so first thing first, I have to get rid of this 2, by the way. I cannot touch the 5. I can't touch it yet. Nope, don't do that. You have to get rid of the 2 first. And that is going to give you a 5 sine. Let me give myself more room here. Be a little bit. Okay, I could do that. I have 5 sine theta equals 2. So obviously I'm going to divide both sides by 2. I'm sorry, divide both sides by 5. Whew. Yes. And that's going to give me a 5 are going to go away by 5 by 5. And that's going to give you a sine theta is 2/5. And obviously you have to use a calculator for this one. with a calculator. Okay, so I put this in, and I will end up with theta equals 23.57, I think. 23.57. Yep. So let's do it again. I got sine, so inverse sine, obviously. Did I jump? Okay, hold on a second. So for this one, you have to use the inverse. So inverse of this amount, 2 over 5, will give you the theta. And let me go here and keep working here. Theta is going to be approximately 23 point. Let me actually do that again. I'm going to do it again. Just let me do it again. Second sine, 2 over 5. 2 divided by 5. Got 23. Second sine of 2 over 5 equals 23.57. 57. Probably, I mean, obviously there's more numbers here. So theta for us is probably maybe 24. Depends on how you want to round up, round down. It just depends on how you do things. Okay. Round, in this case, going to be rounding up, but that's about how much I got from this one. Now, this is from 0 to 2 pi. And let's see what's going on here. Is this the only option? 0 to 2 pi. I'm sorry, 0 to 2 pi. 0 to 90. Okay. Think with me a little bit here. If this guy is actually here, so 24. So I'm going to say maybe, where's my circle here? Let's say I have a circle here. And it turned out to be that this guy is 24. So somewhere here, 24. Now my question is, this is all student take calculus. Remember, your limit is from 0 to pi. From 0, I have all the way to here to think. My options are here, all the way from here. My options are from here, this side, all the way to here. I have options. I could use options for the sign that is positive. So apparently there's another angle, correct? There is another one. There has to be another one. Because all student, that means sign is positive here. So there is another one. How do you know the other one? Well, you use the same reference angle. Remember reference angle? The closest to the x-axis? So you're going to go back here and say, oh, hold on, I know. There's a 24 degrees here, which means if you subtract 180, I'm approximating here, okay? So I'm going to say 180 minus 23.57, excuse me, 156.4. So this angle is theta is also 156.43. Perhaps theta is 156 as well. So both of them are options. Yeah, because both of them have a positive sign. Both have positive sign. You could tell this is positive here. All student also sign is positive. That's what you got. You have an angle that is positive. You have the angle that has a positive value in the first or the second quadrant in this case. Here's the last one. Find all solutions to the equation of the interval from 0 to pi, once again with a calculator. So I'm going to follow my procedure. I'm going to add 6. And I'm going to use this line. Back here, I'm going to have myself 7 cosine theta equals 6. I divide this by 7. Divide this by 7. I'm going to get myself cosine theta equals 6 over 7. Again, this is not a known value. I don't know. It's not a 1/2. It's not a 1. It's not a 0. So I can't use just the unit circle knowledge primarily to solve this. I could use the unit circle knowledge to help me find the number of solutions. But thus far, I can't just depend on the unit circle. So I have to use a calculator. Obviously, here's the calculator. So I'm going to go and then put that in. I'm going to say cosine. So inverse cosine, remember, you have to set this up correctly. You're going to say cosine inverse. For inverse cosine, let me give myself more room here. Will give you what you want, which is the 6/7 value. That's going to give you a theta that you're looking for, or the x. And then that's what's going to help us find the remaining values here. So let's do that. I'm going to do second, and then a cosine. I have a 6/7. Okay? And that's going to give me 31. So theta approximately, good job those for you on the chat, I see that, approximately 31.002 ... Okay, so I'm probably approximating that 31 degrees. That's one option. The other question is this, which I asked earlier, by the way. If this is true, but this is true for the first quadrant. Why is that? Because in the first quadrant, all of them are positive. Remember, this value is positive here. This guy is positive. This guy is positive. See that? Positive. Which means cosine is positive. Well, cosine is also positive somewhere else on the unit circle. Where else is cosine positive? Think with me. Where else is cosine positive? All? Students? All students take calculus. So it is positive in the first, which is what they just gave me here. Well, I just got that from this dude. I got that here. 31, about 30, so 31. And also there's another 30 somewhere here that is positive, which is this down here. I have a positive cosine down here. So let's put that, I'm going to choose a different color, obviously, for a reason. So I'm 31 degrees away from my axis. 31 here. 31 away from my axis. So which is, if this is 330, so this is actually 330. So 330 is going to be 329. Okay? So this is 31 degrees. This is 329. Question is this, though. Let me be very careful. I have to follow my limits. Am I limited? The answer is yes, my dear. You are limited. You only could go from 0, including 0, all the way to pi, which is 180, but not the pi itself. Which means automatically I have to reject this here. This is not acceptable. It's fine for me to think about, but not acceptable. It's not acceptable because of this fact. So you do not want this again. This is not, let me choose a different color for that. This is not, I'm just going to reject this. This is rejected. The reason is because you have to be between 0 and pi. Okay, wow, that was a good lesson. This is for you to quiz yourself. So if you're watching this afterwards, please make sure that you pause here, give yourself time, think, do the problems, and this would be a good place for you. Probably maybe put a timer or something if you are getting ready for the SATs and the alike. Make sure that you start timing yourself when you do problems. Okay, and these are the solutions here. Make sure that you follow what it says, by the way. One of them is without a calculator, the other one is with a calculator. All right, here we go. Down to the last minute. 1 minute of hope with Armani. I feel with all of you, with all what's going on here around us, I want to say something that really motivates me. It does motivate me when I see you guys really engaged in learning, although this is optional at the moment, but you are building the foundation for the next math classes, right? or for your college math classes. And I highly recommend that you just be at peace. Things will be fine. Trust me. Things will be okay. God is going to take care of us. He always does. He's with us in the tough and in the rough spots in our lives, as well in the easy spots of our lives. Valleys, He's with us. Mountains, He's with us. So we just have to trust in Him. In God we trust. And we're going to place our trust in Him. He's going to carry us through and carry the whole nation through this, and actually the entire world through this pandemic. Be blessed wherever you're at. And you guys, I love you. If nobody said I love you today, remember, Armani does. Okay? Take care, and God bless.